这是不管大，不是别的。我在这里的时候也是在想着有没有啥，傻了就这样。
Okay, good morning, class. Okay, today we look at this transfer function. This one's supposed to be done the last week. This is just a small subtopic. Okay, transfer function. This one. Have you been come across this transfer function, this term, in any of your engineering subjects, especially in signal and system? If not signal, do you take signal and system this semester? Or control? Control.
No.
So you haven't come across this transfer function before. Okay. Let's go. Okay, this transfer function is the method we represent system dynamics. System dynamics in S domain. Okay, in S domain representation from Laplace transform. Okay, so actually the transfer function it shows the flow of signal through a system. Okay, flow of signal through a system from input to output. So for this transfer function, we will assume all initial conditions to be zero. Okay, this is our assumption. Okay, when you look for the transfer function, we assume the initial conditions are all zero. Okay, so this is an equation that has an input and output. Okay, so this one Ft is the input. Okay, Ft is the input. And when you solve for this differential equation, your final solution is Yt, right? Yt. This is your final solution. When you solve this, okay, when you solve this differential equation, your final answer is Yt. Okay, so this Ft is the input, your Yt is the output. That means that is your solution. Your solution, final solution is Y in terms of T. Okay, so this solution is the output. Whenever you have a different input, you will get a different output. Okay, this Ft, the right hand side function, is the input. Okay, so this is the transfer function. Okay, this is the transfer function. Okay, just now the input is Ft, your output is the one in T, X in T. Okay, let's say X in T. So the transfer function is a fraction function where we have output over input. Okay, output over input. Okay, let's say your output is X. This one X in S, and your input is F in S. So the transfer function, we denote the transfer function using H. Okay, H transfer function. And remember this, your transfer function is output over input. Okay, that means X over F in terms of S. Okay, so this one, once you get your transfer function, okay, you inverse Laplace the transfer function, you will get the impulse response function. Okay, the response function. Okay, we look at the first example. Find the transfer function for this system. Okay, where Ft is the input, Yt is the output. So to get the transfer function, we have to Laplace every single term. Okay, Laplace every single term. So this one you have learned. Okay, y double prime. Laplace y double prime, you get this. Okay, Laplace y prime, you get this. And Laplace y, this is not a derivative. So we just get capital Y in S. So Laplace lowercase f in t, you get capital F in S. Okay, so after Laplace every single terms, you should get this. And now we are looking for the transfer function. To find for the transfer function, we will assume all initial values to be 0. Okay, to be 0. So that's why this is 0, this is 0, this is also 0. Okay, now after that, you simplify, you factorize the y in S. Okay, you get this line. Okay, now we want to find for the transfer function. Transfer function is output over input. Okay, output over input. So the output is y. Input is f. Okay, so we have output y over input f. Okay, this is our transfer function. So we want to get y over f from this equation. Okay, to get y over f means that this f we bring to the left and this function we move to the right. That's why you get this. And you got to see the relation, how you get this. Okay, I repeat, your transfer function is the output over input. Okay, output y over input f. So to get the y over f from here, y over f, that means f, you move the f to the left, so that the right hand side you have 1. Okay, after you move f to the left, right hand side you have 1. And this function you move to the right, you have 1 over this 5s squared minus 3s plus 7. Okay, so the y over f is the transfer function. Okay, so this is your transfer function. Any questions? Yeah. Okay, this is another example. This example actually I took from the engineering subject. Okay, this is an example from the engineering subjects. I can't remember. Which subjects, but this is from the engineering book. Okay. So find the transfer function for this system where the Q is the input, W is the output. Okay, now we know that Q is the input, W is the output. To get the transfer function, we need output over input. That means W over Q. Okay, this one we need W over Q. Okay, now we Laplace transform every single terms. Laplace transform every single term. You get this. Okay, suppose you have learned how to Laplace transform the derivative. Okay, shouldn't be a problem for you to write this line, and then you just we assume all initial values to be 0. So you substitute the initial conditions by 0. Okay, and simplify, you get this. So transfer function is this one, output over input, W over Q. Meaning that we move this Q to the left and we move this one to the right. And this is your transfer function. Okay, transfer function actually is quite simple. Okay, if you know that transfer function is the output over input. Okay, now we try this. Find the transfer function, okay, that governed by this differential equation, where okay, f is the input, y is the output. Okay, once you get your transfer function, find for the impulse response function. Okay, impulse response function means that you just apply the inverse Laplace. Inverse Laplace the transfer function, you will get the impulse response function. Okay, find for the transfer function. Okay, where f is the input, y is the output. Okay, this is input. Okay, y is the output. Okay, Laplace transform every single terms. Okay, Laplace transform all the terms that you have this one plus 4 y prime plus 20 plus y. Laplace transform the term.
我记得一个 S 的，
Verify coordinates. Okay, then all the initial values are 0. 0, 0. Okay. So factorize s squared plus 4s plus 20 I in s equals to f in s. Okay. So the transfer function is denoted by h. Okay, this is output over input. Output over input. Okay, output over input. So to get the y over f, okay, this one y over f means that f you bring to the left. Okay, there will be 1 here. Then this one you move to the right. So you have this 1 over s squared plus 4s plus 20. Okay, this is the transfer function. Okay, next, to get the impulse response function, we have to inverse Laplace the transfer function. Okay, the ht, the impulse response function, this is transfer function. This is impulse response function. Function ht, okay, lower h, a lowercase of h with t. So we inverse Laplace this function. Okay. So to inverse Laplace this function, you know that
complete the square.
we have to complete the square. Okay, and write it down here. n squared plus 4s plus 20. Okay, you complete the square for the function. Complete the square. You have s plus 2. S plus 2 square minus 4 plus 20. Okay, simplify. S plus 2 square plus 16. The inverse Laplace this function, we apply the first translation. We want to take out the plus 2. So inverse Laplace, we take out plus 2. You have e negative 2t. Okay, e negative 2t. So what is left in the bracket? S squared. Okay, S squared plus 16. So final answer is we need a 4. So 1 over 4 e negative 2t. This is sine 4. Thanks. Okay. Any questions? If no, we look at question number 2. Okay, for question number 2, we want to look for the transfer function. Transfer function. And according to the question, R is the input, C is the output. Okay, C is the output. R is the input. Okay, so Laplace transform all of the terms this exercise I took from the engineering subjects books. Well, okay, you will have something like this. Okay, to get a transfer function, okay, you Laplace every single terms, and if you substitute the initial values by 0, suppose, okay, you should get a 1 s cube. B prime plus 10C equals to the right hand side, S square capital R in S minus 5 S R N equal memang ada proporsional.
Sudah bisa naik foto. Di 13 bisa.
13.
Sudah tahan. Sudah tahan.
Nanti lepas dari saya siapkan ini. Oh kita.
Yang pakai di tak boleh kita hari yang sudah tarik. Jadi kalau kita tak tulis lagi.
Oh, sudah mendaftar. Semuanya. So all initial values are 0. Yeah, if you know how, if you know all the initial values are 0, suppose you know this is the only term from here. This is the only term from here. It's the only non-zero term. Okay, so factorize plus 6x squared plus 10 s squared s squared minus 5s plus 3. Maybe by the time you have already mastered the ring, okay, that's one. You can go to this. Okay, straight away you get this. Okay, so the transfer function. Okay, the transfer function is output over input. Output over input. It's C over S. That's C over R. C over R means that R bring it to the left, this one bring to the right. Okay. Any questions for number 2? Now we look at the last one, number 3, for the transfer function. Okay. Find the output response if transfer function is 1 over s plus 2 and the input function is 1 over s. And we want to find what the output response. Output response. Okay. Output response, let's say we let the output function to be gs. Let's say gs. Meaning that your transfer function is g over f. Okay, f is the input. Okay, f is the input. Okay, let's say the g is the output. So this is your transfer function. Okay, now we want to find what the output response. Output response. Response means the impulse response function, the one that you have to carry out the inverse Laplace. So gs, to get gs, we have to multiply the h with the f. So hs multiplied to the fs. So meaning that 1 over s plus 2 times 1 over x. This is output function. I'm sorry, this is output function. Gs. The output response is the lowercase of g. That is called impulse response function. So this one, how do you solve the inverse Laplace? Output response. Output response is h in t. G is lowercase of g in t. Okay, that's mean inverse Laplace of this 1 over s plus 2 times s. Okay, how to solve this inverse Laplace? Okay, you can use partial or convolution theorem. Okay, which one do you want to use? You want to use convolution or partial fraction? Convolution. This is an option for you. Okay, if you want to use partial, I show partial. If you want to use convolution theorem, I show the convolution theorem. So, partial. Okay, it's partial fraction. So a over s and b over s plus 2. Okay. So combine, you have a s plus 2 plus b x. So we can choose s is -2 and also 0. Okay, let's say s is 0. So we have 2a. 2a, meaning that a is up. When s is -2, s is -2, we have -2b. Then your b is negative out. that we have A over S plus negative half over S plus 2. Okay, so inverse Laplace of 1 over 2 over S, factorize the 1 over 2. So you inverse Laplace 1 over S, you get 1. Okay, minus, okay, factorize the half, factorize the half. Inverse Laplace of 1 over S plus 2 is E negative 2t. This is the output response. Okay, output response. This is the output function. Okay, any questions? Any more questions for transfer function? Okay, now we transfer to another room. The next door, BK 13. Okay, because here is too stuffy without the aircon. Okay, those who join online, you remain in the group. Okay, later I will. Listen and we need to.
那会在也关键的传言。
Guys, what's happened? Why is it the board not showing? Hello. Someone should answer me.
I don't know what's the reason to do it. Maybe the doctor is closing the screen.
Oh,
I'm not sure.
this is my failed online classes. Oh. Ah.
Because Ahmed he asking, so that's why there is no screen.
Okay. Let me tell you, this one, closed loop transfer function. Okay, with this one, this subtopic is not covered under this course. Okay, I include and I introduce in a class because in the subject of control, I think subject of control, the engineering, the engineer, the lecturer that teach the engineering subject of the control, she complained to me that students do not know how to simplify the function, something like this. Okay, so I just introduced it. Okay. Okay, this is a simple feedback control system. Okay, simple feedback control system. And it is a closed loop. Closed loop meaning that from the before the output, we have one loop that goes back to the as the input. That means we will present some feedback and we put into as the system as the input. Okay, this is a closed loop control system. So this is our input. This is our output. Okay, so here we have a controller, which is the GS controller, and we have a sensor that collect the feedback, okay, and for the improvement, okay, to be fed into this system. So the sensor is denoted by K. Okay, K. So the transfer function of a closed loop transfer function, okay, the transfer function for a closed loop control system is given by this one. Okay, it is still the same output over input. Okay, output over input for the open loop. Okay, open loop that's mean without this part. Okay, without this part, this is open loop. So input, we feed in the input into the controller, where we get the output. Okay, that is open loop. Y over X. But when you have a closed loop, a closed loop system, your transfer function will be this one, G over 1 plus G times K. Okay. So for example, given a simple feedback control system, this one, find the transfer function when gs is this one and ks is one. Okay, you are given the g and k here. G and k are given, and you just need to put them, substitute them into the formula, and then simplify. This is the problem where the lecturer complains. Okay, this one, the gs1 over s plus 2, 1 plus g times k. Okay, this one 1 plus g times k, because k is 1. So to simplify this one, first we will multiply this one to the 1. Okay, so we have 1 over s plus 2. This one, 1 over s plus 2 plus 1. Okay, when you plus 1, means that s plus 2 over s plus 2 plus this one, right? When you have 1 plus this function, we have s minus s plus 2 over s plus 2. This 1 is s plus 2 over s plus 2 plus this function. That's why we get s plus 2 plus 1, s plus 3, right? Is that? Then here, this means a divided by b. Yeah? A divided by b, that means a times 1 over b. This is your b, this is 1 over b. So we just cancel out the s plus 2, we get 1 over s plus 3. Okay, this is how we simplify the function. Okay, since this is not included in our syllabus, then this is supposed to be finished in the last week. So this one, I just leave it to you to have a try. Okay, so you can try on your own. You are given the g and k, and the final answer is given in the slide. You can try it. Okay, trying to simplify it. Okay, so now we have done this chapter 3. Chapter 3, that's mean the 3 is the Laplace transform. Next, we will move to the chapter 4. Chapter 4, Fourier series. Okay, this Fourier series, for every year, there will be one question of the final exam. One question from this chapter. Before that, maybe I can show you the past year question for this Laplace. Laplace. We have a look question of the past year, last year. Okay, last year. Find the inverse Laplace. Okay, I think this one shouldn't be a problem to you. This one also, when you want to take out a -3, you make sure this s has a -3 as well. Okay, look at the C. Solve the differential equation below by using Laplace transform. This one is simple, right? 7 marks. Last 2 years. Okay, last 2 years, this one. You are given this. Okay, we want to find for the transfer function. Okay, transfer function. I think all of you know how to get the transfer function, just like how you have done just now. Then find for the impulse response function, inverse Laplace. Simple, right? Okay, this one. Okay, B. Calculate the inverse Laplace transform for the following function. Okay, this one. You can use either Laplace transform, the partial fraction, or the convolution theorem. Okay, either one. Okay. Either one, because it doesn't state. Okay, it doesn't state it doesn't specify the method. So you are free to choose either you want to use partial fraction or convolution theorem. Okay, for B. Now, if you look at C, the theorem on convolution, blah, 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 blah. Okay, this is the formula given by convolution theorem. Okay, inverse Laplace. Okay, combine the use of Laplace transform. Okay, and the above theorem to solve the initial value problem of this. Okay, so in other words, it wants you to solve this differential equation by using Laplace transform and also the convolution theorem at the last part. Okay, you have to understand what it wants. Okay, combine the use of Laplace transform because we can solve this. Actually, we can solve this by using the relation of parameters or the undetermined coefficients method. Okay, but since it want you to use the Laplace transform, so you have to use Laplace transform. Okay, you have to use Laplace transform. And also, when it comes to the inverse Laplace, you have to use this convolution theorem. Okay, this is what the question is. This one is a little bit different because this is during the time of the online exam. So we just refer to the conventional one. Now we look at a new chapter, Fourier series. Okay, so there will be one question for the final exam, which is comes from this Fourier series chapter. Okay. So before you form the Fourier series, you have to know what is a periodic function and how to identify whether the function is even or odd. Okay, then we will move to find for the Fourier series. Okay, so what is a periodic function? Okay, given this fx equals to x. Okay, this is fx equals to x in the interval from 0 up to 1. Okay, from 0 up to 1 in this interval, we have this function fx equals to x, meaning that this one. Okay, so this is the graph of this function. And this is, there's no repetition in the graph. Okay, no repetition. It doesn't, you don't see any repeating of this line here and here. So this is considered a non-periodic function. Because a periodic function, for a periodic function, you will see something like this. It will keep repeating. Okay, the main segment of the graph repeat from negative infinity up to infinity. It's like the sine x, cos x, the sine x, cos x, all the trigonometric function, they are oscillating from negative infinity up to infinity. So all trigon functions are periodic function. Okay, so how to change this non-periodic function into periodic function? Okay, you can have one more line here. This one. Okay, when you see something like this, one more line after the function. Okay, this one. This shows that this function is a periodic function. Okay, you insert one more line where fx equals to fx plus p. Okay, this is p period. Okay, period. That means what is the length for one full cycle? Okay, the length of one full cycle. Okay, this is the graph of this x. This is the graph, and the period is 1. Okay, 1. The distance in the interval. Okay, so 1. So this as one full cycle. Okay, this as one full cycle is representing the period of 1. Okay, so if we want to create a periodic function from this, okay, means that once you have sketched this graph, we will copy and then paste on the left and on the right. Okay, in the interval of this 1 unit. Okay, this means everything that copy from this interval, you paste on this interval. This is also 1 unit. 1 unit. Okay, so this is a periodic graph. Okay, a periodic graph. And this is called periodic function because the graph is repeating or recurring. Okay, all trigon functions are periodic. Okay, with a period of 2 pi. Okay, a period of 2 pi means that all cos, sine, tangent, you have one full cycle in 2 pi. Okay, this is a sine function. So up to this 2 pi, this is one full cycle. This is the sine x. Okay, sine x, one full cycle. And then when you copy this and you paste it, you get another one. Okay, another one up to infinity. So same goes to the left hand side. You copy this 2 pi, okay, 2 pi, from 0 up to 2 pi the graph, and you place it on the left, you will have something like this, continue. Okay. So this one, even though we didn't write this for triple function, we know that triple functions are periodic functions. Okay. This one, normally when this function is a periodic function, we will have one extra line. But for all triple functions, without this line, we also know that there are periodic functions with a period of 2 pi. Okay, that is the fact. Okay, that's the fact. Okay, now periodic function. This is by definition. Okay, this is the definition for periodic function. Now, what is this P? Okay, P is the smallest positive number. Okay, smallest positive number. Okay, that's mean 0 is not included under this P. Okay, P can never be 0. Okay, because 0 is not positive. Okay, 0 is not positive. So when we want to find for the period, okay, so we can make use of this equation to find for the P. Okay, but of course, okay, if f is a periodic function with period P, okay, if we know that f is a periodic function with period P, then okay, from here, okay, we know that fx plus np equals to fx. Okay, because P is the periodic function. For example, a sine function P is 2 pi. So 2 pi, after 2 pi, you get one full cycle. Okay. After 2 pi times 2, let's say n is 2, n is 3. After 2 pi, 4 pi, 6 pi, you still get the same function, right? The sine x. Okay, that's why fx plus np equals to fx. They are still the same graph. Okay. And also fax plus b is also periodic. If f is periodic, fax plus b is also periodic. But the period will be p over this magnitude of a. Okay, so according to this second property, we have this. Okay, for example, let's say fx equals to a sine bx plus c, or a cos bx plus c. So the period will be this one. P is 2 pi. 2 pi over a. The a comes from not a here. This one, the coefficient of x. A is the coefficient of x. Okay, so from here, the coefficient of x is b. Okay, coefficient of x is b. So that's why the period for this function is 2 pi over b. Okay, 2 pi over b. Because we know that the sine function period is 2 pi. Cos function period also 2 pi. So 2 pi over this coefficient of x. Okay, we look at the example. If we want to use this to find for the p. Okay. So that this function is a periodic function and want to find for the p. So how to show that it is a periodic function? Okay, when p exists, that means it is a periodic function. One, when p exists, okay, and it is not 0, okay, then it is a periodic function. So we make use of this equation. Okay, now we substitute x by x plus p. Okay, we make use of this relation. We want to show that fx plus p is equals to fx. Okay, so we change the x into x plus p. So this x will also be changed into x plus p. Okay, this one, fx plus p, here x into x plus p. So that's why this x also x plus p. Okay, so this one, this is cos 3x plus 3p. Okay, cos 3x plus 3p. So we can use the identity. The identity, cos a plus b will be cos a cos b minus sin a sin b. Okay, so that's why we get this. You use the identity to expand. Okay, and then because of this show, right? Show means that we know that this is actually equals to the fx. So your fx is cos 3x. So we equal this to the cos 3x. Okay, so we have this line. Okay, so now we compare. Okay, we compare both sides. On the right, we have only cos 3x. Okay, so suppose this one should be 1, this one should be 0 in order for us to have cos 3x. Left hand side and right hand side supposed to be the same. Okay, so because this is P and we want to find for the value of P. Okay, that's why this we'll say that this is a parameter. Okay, this parameter should be 1, this one should be 0. Okay, in order for us to have this equals to cos 3x. Okay, so now cos 3p is 1, sin 3p is 0. Okay, so to get the p, okay, this is a cos function. This is a cos function. Cos function, it gives 1 when the angle is 2 pi. Cos 2 pi is 1. Cos 2 pi is 1. So to get, for cos function to get 1, your angle should be 2 pi. Okay, and same goes to this one. When this angle is 2 pi, sin 2 pi is 0. This is what we want. This is what we want. We want this to be 0. This one should be 1. So your 3p should be 2 pi. Okay, 3p should be 2 pi. And from here, your p is 2 pi over 3. Okay, your period is 2 pi over 3. Okay, this one, actually, we can also apply the properties. Okay, this one to get p in a very simple way. This one, cos 3x, cos 3x. If you compare with this one, cos 3x, your b is 3, your c is 0, your a is 1. Okay, so the period will be 2 pi over b. Your b is 3. Your b is 3. This one, cos 3x, you can compare with it. Okay, the a is 1, but what we need is b. Okay, the value from b. B is the coefficient of x. So your b is actually 3. B is 3. So the period is 2 pi over 3. You can obtain the period directly. Okay, because we know that cos function is a periodic function. Okay, cos function is a periodic function. Then we can apply the property of the periodic function to get the period. Okay, this is in a much simpler way that we apply the property. We have shown the cos function is a periodic function. Okay, now if we want to find the period for each of this, okay, so what is the b from this? We know that cos is a periodic function. What is the b? You compare this one with this one. What is the b? B is b here, this one. B is 2 pi, right? B is 2 pi. B is 2 pi. So the period will be 2 pi over 2 pi. Then you get 1. 2 pi over 2 pi, because cos is a periodic function. Okay, cos is a periodic function. So the period will be 2 pi over b. Okay, 2 pi over b. We use this. Okay, we use this property. We know that the f equals to cos 3x, cos x. F equals to cos x is a periodic function with 2 pi. So f cos 3x. Cos 3x will be a period of 2 pi over 3. Okay, we are making use of this property. Okay, so this one, we look at the question number 2, sine 5x. Okay, sine bx plus c. So the b is 5. The b is 5. B is 5. So the period will be 2 pi over 5. 2 pi over 5. Okay, for the third one, cos 3x plus 1. Okay, 3x plus 1. What is the b? 3. So the period is 2 pi over 3. Okay, we are making use of the property of the periodic function to get the period. Okay. And next, we will look at the even and odd function. Okay, even and odd functions. So there are two ways. Okay, there are two ways to identify whether the function is odd or even. Okay, normally for final exam question, if you look at the final exam questions, they will confirm there will be one part to ask about the Fourier series, and maybe another part will ask about the odd and even function. Okay. So this one, there are two methods to identify whether the function is odd or even. This is the first method. Okay, this is the first method, and this is the second method. The second method involves the sketching of the graph. Okay, sketching of graph. Okay, we start with the sketching of graph method. So when you sketch your function and you found that your function is symmetrical about the y-axis, then that function is an even function. Okay, even function. If your function is symmetrical about the origin, okay, this is symmetrical about the origin, then that is an odd function. Okay, normally for even function, this is very obvious. We know whether there's a reflection through the y-axis or not. Okay, but for the odd function, okay, how do we check whether it is symmetrical about the origin? Okay, we look at this one. This is the steps. Okay, now we want to check whether this is odd. Okay, whether this is odd. So we take one quadrant, the graph from one quadrant, this one. Then you reflect through the y-axis. When you reflect through the y-axis, you get something like this, right? And this one, you reflect once again through the x-axis, then you get something like this. This one. If it matches, that means it is odd. That means reflect two times, one through the y, then through the x. Or you can through the x first, then through y. You get the same thing. Okay. Any questions? Okay, this is the symmetrical about the origin. Okay, I think okay, this is the method by using sketching of graph. Okay, now we look at another method. Okay, another method where we do not need to sketch the graph. Okay. So f negative x, we check by using f negative x. We replace all the x by negative x, and in the end, if what you obtain is fx, that means the function is even. If what you obtain at the end is negative fx, that means that function is odd. We look at this example. Okay, fx equals to 2x. We want to check whether this function is odd or even. So we replace the x into negative x. Okay, we change this x into negative x. So that means this x must be negative x as well. Okay, then you simplify. You simplify, you get a negative 2x. So this negative 2x is actually negative fx because your fx is 2x. This 2x is your fx. And you have negative fx. When you get negative fx, that means the function is odd. Okay. Another example, this one. Okay, we want to check whether this is odd or even. So we let x to be negative x. Okay, this x to be negative x. That means this x must also be negative x. So we change. Okay, we change this x into negative x. That means negative x squared. Okay, negative x squared plus 1. Then you simplify. This one, when you square this, you get positive. Negative 1 squared is positive 1. So that's why this part you get x squared and then plus 1. And this x squared plus 1 is your fx. Okay. When the output is fx, that means even function. Okay. Okay, the third example, okay, 3x plus 2. We change this x into negative x. Okay, this one, this into negative x, this also negative x. So you get a 3 negative x plus 2. So this one, when you simplify, you get negative 3x plus 2. Okay, negative 3x plus 2. But this is not the same. This is not your fx because your fx is positive, positive. So this is not, okay, not equals to fx. And also this is not equals to negative fx. What should it be for negative fx? What should it be? Negative fx means negative bracket 3x plus 2. When you expand, you get negative 3x minus 2. Negative 3x minus 2. This is not negative 3x minus 2 as well. So it is not equals to negative f. You get what I mean? These two, the first two are simple. They are more direct. But this one, you have to check whether this is equals to fx, no, or negative fx. But it is not equals to negative fx. I think I write on my board. Red plus 2. X is 3x plus 2. So now we want to check whether this function is odd or even. So we let this x to be negative x. Okay, meaning that we have to change this x to negative x as well. And x plus 2. Okay, so here when you simplify, you get this. Get this. But this is not equals to fx, right? This one not equals to fx. Not the same. So that's mean it is not even. And does it equals to negative fx? What is your negative fx? This one, negative, your fx is 3x plus 2. Your negative fx is negative, this one, fx is 3x plus 2. So when you expand, you should get, this is your negative fx. But this is not the same with the negative fx. So that's why not equals to this one and negative fx. So that's why it is not odd and it is also not even. So neither both, okay, neither odd nor even. Neither odd nor even. That means it is not odd and also it is not even. Okay. Okay, try this. Try this. Fine. One A is x equals to 4x cubed. Okay. So when you want to check, use negative x to check. Use negative x to check. So if that's 4 negative x cubed, then you simplify. So what do you get? This one, when you simplify, do you get negative? Negative 4 x cubed. So what is this? Negative 4x cubed is your fx. Okay. 4x cubed is your fx. So when you get negative fx means that this one, this function is odd. Now check for B. Two x squared minus 3. 2x squared, but now no longer x, but negative x. So this one, you get positive, right? Negative 1 squared, you get positive. So you get 2x squared minus 3. 2x squared minus 3 is your x. That's me. Okay, C. Fx is cos 2x. Okay, fx is 2x. And negative x will be cos 2 negative x. Okay, so when you simplify, you get a cos negative 2x. And for the cos function, cos negative theta equals to cos theta, right? That's why you get this. Hence, this is fx. E then okay, and B sine 3x. sine 3 negative x, which is sine negative 3x. And sine function, we have this. And fraction of negative sine 3x. This is negative fx. Okay, any questions? Okay, next we look at the one with graphical method. Okay, the graphical method. Okay, now determine whether this function is even, odd, or neither both. Okay, neither both. So this one, we sketch the graph. Okay, we sketch the graph. From -2 up to 0, the interval of -2 up to 0, you have negative x. Okay, this is the negative x. And then from 0 up to 2, you have x. Okay, in this interval, 0 up to 2, you have x. So this one, this is obviously symmetrical about y exists. So that's why the function is an even function. Or we say that the function is even. Okay. Another example, okay, this one, from negative pi to 0, okay, from negative pi to 0, -2. Okay, this is your y. This is your y. -2 is a constant. Okay, when you have a constant, means that you get a horizontal line. A horizontal line at -2. Okay, at -2. So in this interval, 0 up to pi, this one 0 up to pi, we have 2. A horizontal line that passing through y equals to 2. Okay, so this one, when you reflect this one through the y-axis, you get somewhere here, okay, something here, and then you reflect, okay, reflect this through the x-axis, you get this. So with this is symmetrical about the origin. Okay, it is symmetrical about the origin. That's why fx is an odd function. Okay, any questions? Okay, next one, given a periodic function, okay, a periodic function of period 2 pi. Okay, so we sketch this from 0 up to pi. This one, from 0 up to pi, we have x. X, that's mean this one. And from pi up to 2 pi, in this interval, pi up to 2 pi, we have pi. Pi is a constant. Okay, pi is a constant. That's why we get a one horizontal line at this pi. Okay, and from this, okay, period 2 pi. Period 2 pi means that this one 0 up to 2 pi. This is one full cycle. This is one full cycle. And since we know that this is a periodic function, means that it will repeat. The graph of this will repeat here, here, up to infinity, and also here. From negative infinity up to infinity. So we just paste a number of the complete cycle. So this one, this graph is not symmetrical about y-axis or the origin. Okay, so the function is neither odd nor even. Okay. And now we try this. try to sketch for this one. Question 1A. Okay, F(x) 0, 3, 0. Negative pi x negative pi over 2. Okay, sketch this. From negative pi over 2 up to pi over 2. Then up to pi. Up to negative pi. Okay, sketch this. From negative pi to negative pi over 2. And this interval is 0. 0 means yes. From negative pi over 2 up to pi over 2, in this interval, we have 3. 3 is a constant. The horizontal line. Then the last interval is 0. So Fx is symmetrical above the y-axis, right? Symmetrical above the y-axis. The reflection, this part when it's reflect, yes. Okay, so this is Fx is even, means it is symmetrical above the y-axis. That's why it is even. So the justification whether it is odd or even, you have to know. Okay, for even, it is symmetrical above y-axis. For odd, it's symmetrical above the origin. B cos x and 0. Okay. For B, in the interval from -pi to 0, it is cos. Okay. First of all, you have to know how to sketch for the cost. Cost. This is the cost function. This is 3 time. This is time. Right? This is cos x. But here, the cos x, we just want to take the part from -pi up to 0 in each time. So we x. So this is -2 times. This is -2 times. Okay, we just want the part from -pi up to 0. Okay, this is 0. So -pi is 0 is here, meaning that we just want to take this. We just want this. So this one. This is -1. Okay, and 0 up to pi, you get 0. This one. So this graph is not odd and also not even. So the answer is neither odd nor even. And x is neither odd or even. Okay. From -2 up to -1 in this interval, -1. -1 is a constant. And from 1 up to 2, it is another constant. Okay, from 1 up to 2, another constant, which is 1. Okay, and in between, okay, the one negative one up to one in this interval, x. X, this means this is a straight line. Okay, this is a straight line. You can substitute x equals to negative one. Okay, x equals to negative one. When x is negative one, this is negative one. Okay, so negative one, this is the point. Okay, when x is one, okay, when x is one, this is also one. So 1, 1, this means 0.6. When you connect these two by one straight line, that is the x. Okay, so this one, is it even? No, it is not even. Is it hot? Oh, okay, because when you reflect this one through here, suppose you make it something like this, and you reflect through again through x, you get this. So this is symmetrical above the origin. Fx is odd since it is symmetrical. Above the origin. Okay, so two methods for you to identify whether the function is odd or even. Okay, any questions? Okay, one more stop topic. Okay, but this one is simple. Okay, because this still this is the properties of product functions for the odd and even. Okay. So if you have two functions f and g, and this f and g are both even, so f times g, this function will also be even function. Okay, if both of these f and g are odd functions, then f times g, this function is even. Okay, if one function is even, another function is odd, then what you obtain will be odd function. Okay, this is something like plus plus. When you multiply plus plus, you get even. Multiply minus minus, you get plus. And then 1 plus 1 minus, when you multiply, you get minus. Something like that. Okay, so determine whether each of the following function is even or variable. Okay, this one, okay, x cubed, we are using the same way to identify whether they are odd or even. So x cubed, we let this x to be negative x and we check on this. So this is the negative gx, that means this is odd. And for cos function, okay, for cos function is even. Okay, cos function is even. So 1 is odd, 1 is even. The answer will be odd. Just like plus times minus, you get minus. Okay, x. Okay, x. When you check by using this way, negative x, you get negative x. So negative x is negative gx. So x is odd. Okay, x is odd. Sine is also odd. Okay, remember this one. This is a fact. Cos is even. Sine is odd. Okay, sine is odd. Cos is even. Because of this. Okay, because of this. Cos is even. Sine is odd function. So this is odd. Sine is also odd. So odd, we get even. Okay, we get even function. But of course, this one, you can you can also use this way to check. You can also use the same way to check for the odd or even. The proper way is actually this one. Fx is x cubed plus 6x. So if we want to check, we are still using the same way, negative x. The x cubed, we have negative x. Cos 6 negative x. So this one we get negative x cubed. Cos negative 6x is still cos 6x. Okay, so this is negative, this is your fx. So, okay, we can also use this way to check. Okay, but if we know the odd or even for the individual function, we can also get the answer in a very simple way. When the function you have a odd power, okay, odd power, that means odd. When this power is even number, you get even function. So this is an odd function. Odd function, this is even function. So odd and even, you get odd. Okay. Okay. This one. Okay, suppose all this question, okay. Okay, suppose all this question you can get the answer by using the f negative x. Okay, f negative x. But here, okay, this is even, right? Square. When you have square, that means even. X squared is even. Sine function is odd. Even odd, then you get odd. Okay. X cubed is odd. Cos is even. So that's why odd even you get odd. Okay, this is it's because a constant we can ignore. Sine is odd. Cos is even. So you get odd. Okay. Sine is odd, but with the square of this, it will be even because of the square here. Okay, this one I show you later. Okay, we go to this one first. Cos is even. Cos even, so even, we get even. Okay, and this one I also show on board. Okay, just now the question D, fx is sine square x cos 3x. Okay, sine square x. Sine square x is actually this one. Square. The square here is referring to the square here. Okay, x we change into negative x. And then cos 3 negative x. So this one, we have negative sine x squared. Cos 3x. So this means sine square x, right? Negative square cos 3x. So this is fx. Okay, even. Why we get even? Because this is even, this is also even. Okay, if you look at this individually, okay, we look at this individually for sine squared x. Okay, this is similar. Okay, when we check on this one, this is sine negative x squared. Okay, that means negative sine x squared. Then we get sine x squared. Okay, this is actually sine squared x, which is the fx. fx. So that means this is even. Okay, sine is odd, but with the square, it will be even. Same goes to the cos function. Cos is even. But if you have cos to the power of 3, it will be odd. Okay, but if you want to check whether it is odd or even, you just use this way. Just use this way. Then you can get the answer. Okay, and the last one, f. Your fx is 2x plus 3 sine 4x. Okay, this 2x plus 3 you get a negative 2x plus 3 times negative sine x. Okay, this part actually, this is not the same as the original. Okay, not the same as the original. And it is also not the same with the negative fx. From here, your negative fx, that means this one. Negative 2x minus 3. This is also not the same. Okay, actually, we have already known this is neither odd nor even. This part is neither odd nor even. So as long as from the product function, there is one function is falls under this category, neither both. That means the answer will be neither both. Okay, as long as there is one function, is neither both. That means overall, it is neither both. This one is negative plus 3 plus 3 sine x. So this is actually not equals to fx. Let's simplify one more. 2x minus 3 sine x. This is not equals to fx or negative fx. So neither both. Neither odd nor even. As long as one of the function is neither both, that means overall it is neither odd nor even. Okay, you have to know how to identify whether the function is odd or even, because next, okay, when you move into the Fourier series, you have two types. One is full range. Full range. This week we will look at full range. After full range, there is a half range Fourier series. Okay, for the half range, why we have half range? Okay, because it is either odd or even. Then we have half range. So we have to know how to identify, okay, how to identify the graph. Okay, so today we stop here and we will continue in the next class on this Friday. Yeah, which one? Of what? I mistake this stats. Okay.